Okay, this is lesson 1-6, Relations, Algebra 1. I'm on page 42. I'm going to be talking about relations today. So we do have a word in mathematics that is called relations. Okay, a relation in mathematics is any set of ordered pairs. Okay, any set of ordered pairs. And let's remind ourselves what ordered pairs are. An ordered pair is a number that is graphed in the coordinate plane. If we remember right, this is the coordinate plane. It graphs two coordinates, an x coordinate and a y coordinate. Okay, and we graph x is left and right first, and then y is up and down. In the coordinate plane, we have the x-axis intersecting the y-axis at a point called the origin. Okay, the origin. I'll put that under here. It's O-R-I-G-I-N. It means the beginning point. It's called the origin. So when I look at a graph, we always start at the origin to graph an ordered pair. We have 4 quadrants. This is quadrant 1. And I'm going to move these over here so you can see them a little bit better. This is quadrant Roman numeral 1. This is quadrant Roman numeral 2. This is Roman numeral 3. And this is 4. So if I ask you what quadrant a point is, you will say it using the Roman numerals and not just 1, 2, 3, and 4. So if I'm going to graph this point, and we can call this point maybe A, I'm going to graph a -3, so I'm going to start at the origin, I'm going to move 3 places to the left, and then up 2. So this is point A, and it is in quadrant 2, Roman numeral 2. So that's how we graph those, and this is a relation. Now I can take any relation, and I can have a whole bunch of them. So I'm going to start, a relation can be written 4 different ways. And the first way is ordered pairs. Okay? It can be written as ordered pairs. So these are the 4 ways that a relation can be written. So I'm going to start by ordered pairs. It's a set. Remember, it's a set, so it has to have squigglies. So we have, let's say, a negative. Well, let's start with the -3, 2. Let's just include that. And then let's go 3, 1, and 4, 2, and then a -1, a -2. Okay, so I'm going to graph these points. I'm not going to give them names, but this is the first way that we list a ordered pairs. So the second one, I'm going to erase this A so you can get a good look. 3, 1 is here. 4, 2 is here. And a -1, a -2 is here. So this is 4 points on the graph that is a relation. Okay, so that's one way to write it. Another way to write it is what I call a T-table. Your book, mark these so you know. Your book doesn't call it a table. It calls it a table, but I call it a T-table. I write it differently. They do a block. I go, this is X, this is Y. I go -3, 2. A -1, a -2. I'm trying to go in order. 3, 1, 4, 2. Now, guys, all I'm doing is the X's are here and their corresponding Y's are here, and they don't have to be in order. I like to do it in order because then when somebody's grading it, they see it's in order. It's a lot quicker to grade. Okay. The third way to show ordered pair is I've already showed it, and that's a graph, and that's over here. So that is the third way to show a relation. And then the fourth way is what we call a mapping. Okay, and this is the weirdest one of all, probably. Most people would agree. But it's also one that tells us whether it's a special kind of relation in the future or not. So what we do is we put the X here, and we put the Y here. We create 2 ovals, and I just put a -3, a -1, 3, 1. Okay, and I can mix the Y's up, or I can just put them straight down. It doesn't matter. But then I draw arrows to the X that matches the Y. and this is called mapping. Whoops, this is 4, sorry, and that's called mapping. So these are the 4 ways to do a relation. Okay, so in a relation, we have 2 sets of numbers that are important to us. We have what we call the domain, D-O-M-A-I-N-E, the domain, and this is the set of x values. And then we have the range, which is the set of y values. Now keep in mind that since they're sets, they have to have squigglies around them, okay? So let's take this case here. The domain is a -3, a -1, 3, and 4. So that's the domain. We use a capital D. Now we also use a capital D for distance, but we can use it twice, but we use capital D for domain, and then we have the range is, would be, and I can put that in order if I want, 1, 2, I didn't, a -2. I didn't put it in order. But you'll notice that 2 numbers, -3, 2, and 4, 2 have the same. So let's go back here on this one, and I don't have to list that other 2. I could simply go, from this 4, I could go up to the 2, and that saves me some time, and it doesn't change anything, okay? So either way is fine, and you can list the 2 here, or you don't have to list the 2. Most students do not. So in the assignment, they're going to give you one of these, and you're going to have to write the rest of them, draw pictures, and then they're going to ask for the domain and range. So you'll have to do that on an assignment. All right? In a relation, there are usually an independent variable and a dependent variable. X is usually our independent variable, and y is usually our dependent variable. Now what that means is that in an equation, which we're going to do later on, that we put values in for x and it determines our values for y. So this would be what we call an input, and this would be an output. So just keep that in mind. And so relations can look like all 4 of these, but they act differently. Now on page 44, they have on example 3, it says the graph shows the distance Francisca has ridden on her bike. Describe what happens in the graph. Okay, well, the graph looks like this, and you're going to have to do a couple of these. So here's, it's in the first quadrant, and it looks something like this. And this is time, and this is distance. Okay? So we're going, relations can actually, I mean, even though we write it 4 different ways, we can describe them in a picture. So this is a bike ride. This is Francisca's bike ride. So we need to describe what happens here. Well, she starts out, and she's on the rise, right? As time is going, her distance is going up. But what happens here? Okay, time is still moving, but distance is not, isn't it? So what happens here? Well, something must have happened. I know the book says it's increasing, but the distance remains constant. At this section, Francisca stopped. Something made her stop here. Maybe she stopped to talk to a neighbor or something. So, so she was moving, and then she stopped for a while, and then continued on. Now, you can get more descriptive if you want. If you want to, I don't know that you need to, but you could have said, well, her distance was pretty good at the beginning, and here it kind of tapered off, and it might be because she slowed down or she just was tired or something like that. But there was a problem there. One of the ones I think about is my coffee during time. Okay, coffee, temperature, right? Temperature and time. When I take my coffee up, the temperature's clear up here, right? And it drops dramatically, doesn't it? As I'm drinking it, and now that we have cups that are pretty good, that changes a little bit. But at some point, it meets room temperature, and the coffee stays at room temperature the whole time. So we can look at these things through graphs. So you're going to have to do that on the assignment also. So you're going to have to be able to name ordered pairs. You're going to have to be able to read graphs. You're going to have to identify independent and dependent variables. For example, in this case, time is independent because time is the distance is based on the time that you go. So you need to discuss independent and dependent variables. So this is what we're going to do. The assignment is page 46. It starts on page 45. And it starts on 45. We're going to do 10 through 20 even, and then 21 through 30 all. It's worth 40 points. So this is what we're going to do. And then the next video, hopefully, will show you how to do functions. Okay?